downtown No Bay.
Why?
Everybody's life.
Why?
Why?
Because so people can watch it from home and you can experience the class.
And if you're sick and you're in the health center or in your dorm or something, you can still attend class.
I'll just ask my host parent, hey, can you take my phone so I'm not on it for the day?
What? Laptop?
Can you take my laptop too? I can't get rest when it's just sitting right
To be honest,
there.
that'd be good, because if you're that sick, that would help you rest. I'm fine with all of those.
I just order a pizza.
I just
That's what I do when I'm sick. Just order a pizza. Easy.
Okay, that is live.
sounds like a smart idea. I need to order a pen though for my phone.
We're gonna do a few things. Did we? Oh, you can't even see what I'm doing. I was about to ask you a question, and you're like, not able to. Hmm? All the different connections?
No, it's not only like that. Normally either takes over the top of the screen or the bottom.
Oh, everyone's late.
Now, hold it.
Everyone's late for class.
Does this start at 5 after?
What? No, I thought it started at 10.
10, yeah, I think that bell was wrong. It starts in 5 more minutes. Notes out. I'm gonna ask you, were these filled out in your notes?
Yeah.
I think we did that, yeah.
We did that?
Well, we did the.
We didn't get up to all of it clearly because it's not on the board.
Oh, we have math next.
Did you do your math homework, Dan?
There's math homework.
You tripping, dog.
Wait, was there?
Yes.
Well,
Okay. Maybe on top of your homework.
yeah.
Liam, do you
Oh,
know
so
your?
that's what that math homework thing you did on your to-do mate was.
Yeah, that's maybe why my to-do mate said why more math homework.
Oh.
Hmm.
It's giving us
That would make a lot of sense to me.
That does make sense.
They want to Yeah.
We're gonna go with the rest of the group.
Yeah, and both Chen, Zach.
Yeah.
We got to the ion insurance. We didn't do it.
We did we do, like, do you have this filled out?
I have the top one filled out.
But we didn't put it on the board clearly. So, this task would be to, I know what we're gonna do now. Aha!
Did we get our quest back today?
Nope,
Why?
I didn't mark it.
Why did you mark this?
It's been pillar to post. I'm hoping to get to it today.
I heard that your son's skipping classes.
Yeah, he did, he slept in. He was very panicked.
Yeah, I know, I heard. And now whenever I talk to him, I'm just like, so you're skipping us on your classes?
Oh, I told my mom I was skipping. She told me she'd drown me.
Oh.
So I told her it was just tutorial.
Just a tutorial.
It was just a tutorial.
She was mad because I was on my phone. She's like, why are you on your phone in class? I'm like, I'm skipping.
Getting mad about something else.
Like, it'll be like
Okay, I'm gonna take a 10 moment. A reminder, you cannot be on your phones in class at any time until you've been invited to. We are getting a phone bucket. I need a phone bucket. What should I
You
use?
don't need one.
No, it's a requirement. Every science room, you put your phones in the bucket
Oh.
or the thing. I just don't have one yet. I must have one. Something I can make. And while you're waiting, your notes should be out. You should be on to today's work. It looks like that. Getting ready to go.
Mr. Newfeld.
Yeah?
I actually got my phone binder.
Do you want to run or do you want run? How did you bring the wrong binder? There's only 3 blocks in the day.
Yeah, there's only 6 binders you can grab.
Those are
No, you have a binder for each day. You have a binder for ABC and a binder for
I have
PDF.
3 binders for each day, like one for each block.
That's crazy. That's 6 binders there.
at the end of the year. It's not so crazy. Just sometimes those big binders are like
I still have
explode.
folders.
That's even crazier.
Yeah, that's
Everything
worse.
falls out of there. You're
No.
toasted.
No,
So
only
toasted.
fall out of it once, and I just.
It only
This
fell
is
out of
my
what?
And then I threw
So
it
we already
out.
acknowledged that it fell
My
out.
science binder. Right
Yeah.
here.
Then you have to carry around 3 binders every single day.
Okay.
Smaller binders though.
Yeah.
I can't do that. I have too much stuff in my bag.
What do you have in your bag?
Day student stuff.
Use a different pocket.
Pocket. You might have 3 pockets. One is full of pencils. One has my clothes. And
We'll finish off this, and then we're going to do Lewis stuff.
Stuff for school.
we did
with
finish
the
it.
binders.
You did, but we never put it on the board.
We noticed.
So what I'm going to do is everybody's going to put one on the board.
Yeah. Including a laptop.
And well, I might as well start attendance. We're moving the board. Aiden, Ernie,
Books.
Bowen, Bowen's not here. Graham, Shepherd, Grayson, Jamie. No Jamie. Layla. No Layla. Liam,
Here.
Mari,
Here.
Matthew. Who are the 2 boys that ran away?
Matthew and Nick.
Diaby, Nick, ran away. Noah,
Here.
Rachel.
Oh, there's the bell.
She's at volleyball. Matthew
Terrible.
Baker.
She's skipping class. Rose,
Here.
Violet,
Here.
Yuma. No Yuma.
Then with pen on
We finished this last day, but apparently we didn't get to the point to put it on the board for our notes and to double check it. So what I am going to do, yeah. I may have an extra I can just give you, and then you'll have to do that one quickly. But then you could just rip them apart and put them together with a stapler later, or you could run and get it. Your choice. You can run and get it. Just be quick then.
Why is everyone forgetting this?
Yeah, this is nonsense.
Just don't have a binder. I just put my papers freely in my bag, actually.
That's smarter. I should do that.
Yeah.
Oh, now why is this taking so long?
Last.
Yeah.
Me and Baker, imagine still being an egg right here. I'm fully hatched in this. An egg. Because you're an egg in this.
Okay, this is taking too long for me to pick. I want you to remember your number. 1, 2,
Alright, I got it.
3,
I'm one because I'm always
4,
number 1.
5, 5, 6, 7, 8, 9, 10, 11. That's the one you have to do on the board. Oh, hold it.
Wait, where's 11?
Who is 7?
10.
You
I'm 7.
are actually, what number were you?
11.
So you're 12.
What?
Yeah. Because 7's already done. So that is the number of the element that you're going to come up here and draw right now. Go, go, go. Amazing.
Wait, 7 is done, so we're done.
I'm number 1.
She was 7. You were 8.
Mr. Nicole, I accidentally brought my math binder. Can I go back to Alex?
Okay.
Oh,
You're welcome. I mean, I just let 4 other people go, so this seems to be a thing today.
What happened? I don't know why there's so many dots on it.
Only 2 people can write at the same time.
Oh, Waylon? Wait, what number? No, there weren't any. I don't know. I was number 1.
Oh, did you run all the way to Ellis? Actually, yeah.
What?
That was so fast. That's where DHR we ran. Ran hard, man, just better.
I'm 8.
I think it's a
I'm 8.
Wait.
She was 6. She debated you.
I got it now for you days. I won't know.
In my old like class, we just do that in verses. Yeah. Long as
I will say yes, provided you're back when the last person sits down. If you're not, I'm going to say I never gave you permission.
Let me go around to your
I didn't take you long.
11.
You can wait till I come. Right, yeah.
Okay.
All there. Well done. And let's who is 5?
Oh, Mari.
Curses. Okay, the rest of them we're gonna fill in. I'm just gonna ask you. Matthew. This is 5 protons. What's the electron structure?
2 and 3, and Velos electron is 3.
Excellent. Excellent. More points. We need more points. Who's winning right now? Graham, Mari, and Matthew are all tied for first place. Grayson. Number of protons in aluminum. 13. What would the electron structure be? The electrons.
2, 8, 3.
2,
Valence electrons.
8. Whoop, that's a weird 3, but yeah, and 3 valence electrons. Liam, silicon.
Silicon, 14 protons, and then 2, 8, 4.
Number of valence electrons.
And then 12. Or wait, what? Sorry, 14.
No.
Or wait, I'm so confused. I'm so sorry. Wait a minute, 4.
Valence is always the ones on the most outer side.
Oh.
Yeah. Violet, phosphorus. Oh, you don't have to do E when you do it in a condensed form. 2, comma. 5. Where are your notes?
I have them, I just haven't closed my binder.
Don't close your binder. Keep everything out and open for the duration of the class. Noah Mitchell. Sulfur.
16.
Hold it. Don't. Okay, go. 16 protons.
2, 8, 6. 6, 8.
And I think I'm going to do the last one because I think the point is getting belabored here. 17 protons. We got 2, 8, 7. Valence would be 7. Argon, we have 18 protons. 2, 8, 8. Valence is 8.
Someone forgot the 7 or 9.
Oh, we're going to go over it in just 1 second, and then you can point it out. I'll just continue here. Actually, given that this one is a little different, why don't I actually ask? 19 protons. Nick, what would be the electron structure?
For
Potassium. Yeah.
2, 8, 8, 1.
Perfect. What are the number of valence electrons?
Sorry? 1.
1. And then you continue the pattern. 20 protons, 2, 8, 8, 2, 2 valence electrons. Which one is the one that is incorrect? 9?
Yeah.
What are we missing? Oh, the 7. Perfect.
And also the hydrogen
Is
also
2
right.
protons for some reason?
The hydrogen?
Top
No,
right.
the helium.
No. No, that's the 2 protons correct.
2 protons is helium.
Oh, yeah.
Yeah, that one's good.
Oh, sorry.
It's got 2 valence. So what do we notice? And this is not a trick question. It is intended to be that obvious. What do we notice about the number of valence electrons when you go up and down? Stays the same. Is there an exception to that rule?
Helium, neon, argon.
Louder.
Helium, neon, argon.
Helium, it doesn't go, it's not 8, 8, 8, 8. It is at 2. However, why is that not an exception? What is the same about all these orbitals? Yep.
They have full valence shells.
They have full valence shells. So even though it's not 8, they're all full. So that's why helium acts like the other ones. Since they're full, they're noble gases. They don't have to do much, as we're going to see in a moment. And so that way, these ones are all going to react similarly. Because for the next table, what I want you to do for this one, and we didn't put it up there. Now you started on this last day, I think, right?
Yes.
Okay. So did you finish? Because I don't think you were finished when the bell rang. But are you? Asking as a question. Is your sheet completely filled out on this one? No, is your sheet completely filled out? Nope. So You go up here, and the 7 protons is 2 comma 5, for example, and I'll just redo it quick. 2 comma 5, and then you go, what is the most efficient way that you can do this? And we're actually going to write that as a little note. The most common ion is from an atom with a full or empty valence shell in the most efficient, I don't know how to spell efficient apparently, in the most efficient way possible. And I'll redo that example after you have that done. Because it's very, I don't know how else to word it. But what you do is actually easier than the sentence. Great, listen. You're looking behind expectantly. Okay. If it's actually 7 protons and 7 electrons, what is the actual charge? If those two are the same? 0. So, get rid of that for a second. When we say you want to get to a full shell or an empty shell in the most efficient way possible, you look at this and you ask, would I roll 3 electrons into 5 to make it 8, and then it would be full? Or would I roll 5 electrons away and make it 0, which is empty? Both of those are stable. Which would be easier, adding 3 or taking away 5? Adding 3. So this becomes 8, and if you have 7 protons and now 10 electrons, what's the overall charge? What? -3. I thought I didn't hear the negative part. I thought you said 15, which I was like, what is going on? And that looks like -13, so I'm going to erase all of that, so it becomes -3. Now, if you want to get the charge, and you're ever a little confused, charge, number of protons, minus number of electrons is your charge. 7 minus 10 is -3. It'll work for everything. Protons minus electrons. What I would like you to do, finish off this sheet now that we've reintroduced, because it seems like forever since I've seen you, given that we had 2 other days in a row. Finish this off, put in the charge. I will assign you one to do on the board again. And I'll give you a few minutes, and I'm going to come around and take a look at what you're doing. Who said Mr. Newfound? Yeah.
If it's if the valence electrons are 4, do you
Yeah.
go down or do you go up?
That's a good question.
I have no idea.
You have to pick one. And then when you do it on the board, I'll tell you who's ready. We're working away. Yeah. I just didn't see that for there. No, it didn't. Ooh. You have to pick one. I was gonna say, you can continue or I can do it. So how do you find the charge? Okay. Well, let's do one of them without the charge first. So let's move over and do that. So you went up to 8. And it's 2 comma 6. So what are your choices? What are the 2 the maximum that the second orbital can be? 8. So you either add 2,
Add 2 is easier than
taking away 6.
Yeah.
So do that there, and then we'll do charge. Get it down on paper. 2, 8. Yeah, we're gonna add 2. Okay. Now if you're 8 protons, what's the
Yes.
total number of electrons?
2.
Nope.
Okay.
10. What is 8 minus 10?
Oh, negative something.
Do you have a calculator?
No, I don't need that.
I offer you a calculator. You're allowed. It's
Negative what? Negative 2.
negative 2.
Negative 2. Thank you.
You're welcome. But you do need a calculator for this class. Can you get one?
Yeah.
How many of you have a calculator for this class?
Well, it's just like an all
Yeah, you can. Yeah. In chemistry 11 or physics 11, I think you start requiring a scientific calculator. You're not always allowed the graphing, but to be honest, we would be like you need the graphing
With
anyway.
number 6, would it be negative or
That'll
positive?
be
Or I don't
fine.
think it really matters.
I'm gonna figure that out once I get to it.
Oh God, no. That's chemistry 11.
Oh.
Yeah. Molar mass calculations is, we're just doing electronic structure, and then we're gonna do reactions, types of reactions. We're doing Lewis dot diagrams next. The really big math part that comes with that, that's all that math is in grade 11 pretty much.
Oh.
Yeah. That's why in grade 11 you need the scientific calculator at least.
Yep.
Yeah. Okay, now this one was 2,5, but which ones are the valence electrons?
I know I still don't
The 2 or the 5?
I really messed up. Okay. 2, 8. I thought it was 2, 8.
It is 2,8,
Oh.
but it was 2,5 before. Before it was
I should have
9,
grabbed
it was
my. I
2,0.
gotta grab my.
Which one's the valence electrons, the 2 or the 5? The 5. Now, which would be easier? Oh, so first of all, what is the maximum number of electrons that can go in that second shell? 8. So would it be easier to add 3 to get to 8, or take away to 5 to get to 0? Add 3. What do you? So you add 3 electrons, that becomes 8. So that's where the 8 comes from. So you change the 5 to 8.
What are you saying, though?
Some way to change it. Because what I don't want is to go to, and then later on it's still a 5, so make it 8. Also, it'd probably be easier if you did with pencil. Now that it's that many electrons, how many protons are there? And how many electrons in total? Well, how many are in both shells?
Oh, I thought it was square.
Finish, besides that 2 is
That's okay. 10. What's 7 minus 10?
1, 1, 1, 1, 2, 2, 2, 3, 3, 3.
Negative 3. So that's why the charge is negative 3. Another way to think about it is you added 3 electrons, so the charge has to be minus 3 electrons. So however you get to the charge, you can do the next one like
This
that.
could either be 2 and 8 or just 2.
Yes, we're doing that with all of them, just mirroring them down. Are you good, Trevor?
Yeah.
How are you doing?
What do you mean? I know how to do it. Like,
Yeah.
what do you mean?
That's a good question.
Ask Noah.
With that, that's
So
He's
have
doing it
Noah on.
20 compared to 2.
Oh, oh.
Oh, you can't do both at the same time, you have to pick one.
How do I do this? Dude, this guy can do it.
So what I'll tell you to do is pick one, and then after it's on the board, I'll tell you if you're right or not.
Did you respond?
Yeah, that was nice.
Yeah.
Okay.
How do you do it?
Of course.
I definitely can't.
I was like, yeah.
Okay, do the next one. Okay, let's do the next one. Write down like, so we're mirroring them, it's the same element as that one, so it's 8p, and then in pencil 2, 6, so let's do that.
You know what I tried?
I did not go.
That sounds like something.
I think you're going there. Number 8 is oxygen.
Oh.
The little number on top is telling you the number of protons.
What if it's the element with like 6 protons? Then
Oh, and with 4 electrons?
Minus 6?
Yeah, I-
we shouldn't do that,
Wait,
right?
no.
Oh, you should. Oh, yeah, you should.
6 minus 8.
But aren't we, isn't the goal?
1 second, that's a different question than this. Okay, now do the electronic structure like you do before. You have
It's connecting with the pattern.
same as there, 2, 6.
I can't wait to see
And then answer the question,
No, in math.
You need to make that second one either 8 or 0, which would be easier in terms of the amount of things you add. So make it 8. And now that it's 8, what would the charge be?
It's so easy.
No, 8.
I confuse my trigger.
It wouldn't be 0, would you say? Minus 2. Yeah, there you go. Does that make sense now?
Yeah.
On the other one?
What is the charge for my
Yeah, so if we were in the middle,
Yeah, so like carbon. Yeah.
if the Venezuela would have 4, isn't the goal to have easier 8 mils?
The goal is to be full or empty.
And then what would you write? 0, which is 2.
But 4 is,
Yeah, it is. It's right in the middle.
but that's not empty or full.
Right. So you have to pick one. What are you gonna do?
Oh yeah, so
Are you gonna add 4 or are you gonna take away 4?
I don't know what to write.
What is the like better way or?
Oh no, I'm gonna say you have to pick one, and
Oh,
I'll
it
tell
doesn't
you.
matter.
Oh, and I'll tell you whether you're right or wrong when you do it on the board.
Yeah.
Okay?
That
So
can be
pick one.
either negative or positive.
Yours.
Oh, you gotta.
Okay.
You're gonna put it away.
Yeah. I just asked you. It's 0. Like you can have 2 and 4. Actually, no, you don't. Yeah.
Nick, you have to put away your laptop. No laptops out at any time in your bag, so it's not temptation to open it.
I was just searching up whether hydrogen is the full charge.
You can't have two charges. Oh, yeah. But you just have to pick one. You actually, yeah, you got that whole first one. Can you keep going? Keep going? How are we doing?
I'm confused for this, the helium one.
Yeah?
It's just gonna be.
No, because for this one, helium was, now you had 0 there, but it only had 2. You don't need 0. You can just write, it's 2, you're missing your P for proton. So that confuses me. So that's helium.
I thought it went 3, 4, 5.
And it only needs
I didn't calculate it. I just thought.
Does this one need to add any or subtract any? No, so it just stays the same.
How is it not 0?
Yeah, that was just fine. No charge, because they don't need to add or subtract any. Yeah.
How come? Actually no. Yeah, hydrogen has a positive charge. Okay, yeah, sorry.
Well, hydrogen also.
Yeah, it can also have.
Yeah, you gotta pick one.
But it doesn't matter.
Yeah. Yeah.
So I can write like
It's
this.
good. Keep going. You need it.
So why did they, for example, like, for these elements, we can have these like ions, but why wouldn't they do that for hydrogen?
You guys keep working.
So here, for
19. Right.
no.
Yeah.
Instead of you.
Oh, look, why do you have more? Well, why do you have 2 there? You can take them all away. None.
Okay, yeah, you were right.
There we go.
I thought that was 2.
Oh. Wait, no, look. Plus 2. Yes, we're on 1 4.
Come on up. Come on. Come on. Come on. Come on.
Yeah, bro, I wanna know. Okay, now.
If you are still working, finish up. If you are completely done and you would like to know why some of those middle ones have multiple charges, or like something extra, just come up here. Yep, come on up if you'd like to know a little bit extra. I'm just waiting for this to load. Go, 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 go.
Because I am
Academically up there. Why is this not taking so long? I just want a periodic table. No, you're not allowed to know. Yeah. Oh, you can't show them.
Get us this
Just physically block it. Yeah. Why? Maybe. Maybe if I did this. Do I have one in like one of the pictures? Gallery item. Nope. Game memes.
No items.
Oh, no items last
There's
picture.
no.
What? Oh, it's smartboard content files. In there is like a bunch of lions because it's Pride Day and they're all different. They're rainbow colors. Why don't I have the gallery then? Okay. Oh, I got it now. Haha, it came up. So, because I need something I can draw on to actually show you this in a way that's useful. How many of you have heard of SPD orbitals? Okay, so you haven't done that yet.
Why are you just staring at me?
What? Staring at me?
Where's the thing? Oh, there's the thing. Huh, excellent. Okay, very, very quickly. So you know about the 2-8-8 rule that we're using 18 for more, right? And I've already told you that's a lie. But we do know that it's mirrored in here, so I'm going to use this mirror to explain it. So I'm not saying they're here, but it mirrors it. So when we say 2, there is an orbital that you can think of as here that is these 2 spots. So if we were to do it separately, I would say here's your nucleus, and you have an energy level above that that fits 2 electrons. We draw electrons with little arrows because they have a property called spin, and when they're together they have opposite spin. That is known as the 1s. When you go up, you get another one, and that is known as the 2s. You can fill it up, and then you have 3 more. This is known as the 2p. It fits 6 electrons, that fits 2. They're both 2, so in total, that's 8. Okay? Now, if I went back to the periodic table, the reason I use that to model it is that when I'm counting along, you can think of this block as the S, and this block as the P. Because I go 1s2, 1s, and when it's full, I go 2, and then 2s, and when it's full, I go 2, and I go 2p, and when it's full, I go 1, 2, 3, 4, 5, 6. So for something like oxygen, instead of a Bohr model where I would say it has 2, 1, 2, 3, 4, 5, 6, I would say it has a 1s orbital, and it has 2, and then it has 2p, and it has 1, 2, 3, 4, 5, 6. Okay? And this is exactly the same as saying that it is a 2, 6 in Bohr. And in Bohr, you would say, oh, that's the first orbital, and this is the second orbital. That's all those 1s and 2s mean. So these that, sorry, 1s, I didn't do that right, because I forgot about that one. 1s2, 2s2, 2p, 1, 2, 3, 4, 2p4. So here's the first energy level in Bohr where you'd say it has 2. Here's the second one where you'd say it would have 6. It is in the second level, we can see that. S and P refers to their shape. Not particularly important, but S is spheres, and P is dumbbells. Literally like that, 2 electrons fitting in each one. So you've got a dumbbell like that fits 2 electrons. 1 electron makes that shape too. It's not like there's one in each lobe. And they make different shapes. This area is known as the D, and they look more like butterflies. You start getting the actual shape. But your question was, why do some of these have multiple charges? Now, I know in your text it'll say this has a +3 charge. It actually also has a +1 charge. So when we're doing right now, we're just adding or subtracting electrons to make it either empty or full. The difference is if I did this one, I have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then this is the 3d1. It's got 1 electron in this particular one. We count, this is the first energy level, that is the second energy level, and this is the third. Now all of these are inner electrons, they're not valence. These right now are valence electrons. If you get rid of all 3 of them like you traditionally do, you get a +3. But it turns out if you just got rid of that one, this is a full shell. You've emptied that one, so now it's just +1, and that's stable. And the other thing we will eventually tell you next year is that we've told you that full and empty are stable. But when we get into the D, full and half full can be stable. So when you go 1, 2, 3, 4, 5, 6, this one could get rid of 1 electron to become D5, and then it's stable. It could get rid of 2 electrons here and become more stable, and it could get rid of that one and both of those ones and become stable, because then that's empty and that one's full. So the electrons are doing things in the sub-levels, and that gives you more possibilities. Does that make sense?
Yes.
Kind of. Now, on a practical level, the first thing you're going to do in Chemistry 11 is you're just going to be able to rattle that off for every element. So you just know, like, this is the S, this is the P, and this is the D, and then we would say, oh, hey, what's phosphorus? And you'd go 1s2, 2s2, 2p6, 3s2, because we're down 1, 2, 3, 3p, 1, 2, 3, 3p3. And then once you can do that, and you're getting a more accurate electronic structure than we're doing right now, then you can start looking at what the ions are. So that was your advanced topic for today. It'll make a lot of sense in a moment, because I'm going to ask you for the valence electrons in iodine. I might as well do this now. Is that notice all the way here, it went 4 and then 3. This actually belongs in here, but it doesn't get filled until after there. If you are here and you fill every single one of them up, so that was say 3d10 gallium, 1, 2, 3, 4p. Once this is 10, it actually drops to here, and that is actually no longer one of the valence electrons. So once you fill it up, they're no longer part of the valence, and so iodine has 7 valence electrons, even though this is in the middle.
How come you took away 1 ion or 1 electron there, and then it became? Oh wait, can you repeat like what you did?
Sure. So at the beginning.
Yeah.
So
yeah,
for this one, this was for scandium.
Yeah.
We would normally in board we'd say, oh well, we want to either add all of this or take away 3, right?
Yeah.
But these are different orbitals. Whoops, I needed to color there. This is the 4s2. That's those 2, and this is where the 3d started. In this case. Well, it's no longer like take away all of them. These are different. That's the 4s, that's the 3d. Those are different orbitals. So if we just take away 1, it's now more stable, and it's an ion. And so that is the Sc plus 1 ion. The Sc plus 3 ion is when the atom reacts and it takes away all of them, and you don't have either of those anymore, and that's its electronic structure. And it got rid of all of its potential valence electrons. Now, I just did extremely quickly what they spend about 3 or 4 days on in Chemistry 11. So you're like, that's a lot. But it just helps you see that there's an underlying structure that we're not going into. The Bohr model is like big and bulky and is not telling us about anything about this inner structure. That's where quantum comes in and starts telling us about the inner structure.
These are non-valence, right? Like these.
These are valence.
Both. Yeah. Okay. Oh, these are.
But once the 3D is full, because it's still in the third energy level, its energy drops out of the valence and it goes back with these inner ones.
Oh, okay.
And it actually, they call it relaxes and it goes down. And now you only deal with the 4S and the 4P. Yeah. Is everybody done? Okay, I'm going to call everybody to the board. Have a seat. Have any of you seen that for 1S2, 2S2, for any of that before? Did you do it last year?
Yeah, Mr. Doler told us that there's extra, but like he
Oh, but he didn't. Yeah, that's Chem 11 details. Yes? Not now. Now you have to come up to the board. That's crazy talk now. Okay, remember your number. I realized last time I started at 1, and if I do that every time, it makes this spot the easiest. So, 20. What one do I have to skip? So, 20, 19, 18, 17, 16, 15, 14, 13, 12,
What the?
11, 10, 9.
Where'd it
On the
go?
board.
Oh, your posture's so bad, bro.
Yeah.
You're like this. No, I can't, Liam.
The neutral?
Oh my god, what did you do?
Negative. I give up, Liam. You do it.
Depends where.
You do it. You do it.
Like,
I do. My
That's
husband
fine.
you don't mind anything. But if I on there, where it says charge, it's right zero. Yeah.
Thank you for wishing me happy birthday.
Why are we
You're
moving
releasing-
around so much?
Go to bed.
You're writing all those things.
Liam, 2 at a time.
Dude,
Artie's drawing.
waiting.
Hey,
You're the same
how nice to meet you.
No.
No?
I love you.
What house are you in? Ellis, and you're in? What? Yeah. I was trying to prove it. I would hope
Is
I
Whittle
would
really
remember my
nice?
students.
Is it
Yeah.
really nice?
It's a nice one. It becomes a friend.
Well, it's not fair if you guys.
Mr. Barrett's place is crazy
No,
nice.
not compared to Whittle.
Mr. Barrett's place is crazy
Oh,
nice.
they're always
we
well
had-
rested.
Burn down the house again?
Mackenzie's.
No, we had bought some matches, and then I lost a box
Gotta
of
get a
matches.
little
I ran
injured
out
house
of Rogers
digging.
and Whittle and bought some
Oh,
at night, so that was fun.
this is a night. What?
It's a naked mom.
Why is
I
it too
give
big?
that like
Naked
12.
Buddy,
Because you can't find the problems online anymore.
can somebody stop writing already?
So it's actually more valuable.
Protons 11, what's it?
It's not online. And if you ever have a global pandemic and people don't have good internet connections like half
That's
of
pretty
them,
gay.
I use that when
I
I'm.
don't know what's right.
No, it's PC.
Okay. I want to put it back. It's
I
satisfying.
want to use it. Wait, no, give me my sheet.
Man.
I thought it was 9.
If you go back,
Mr. Doler told us about like electro.
1990. Mr. Dole told you.
It gets worse. On the water.
Who is 12?
Oh, glad.
I'm at
Do we write it like
Would that be
with
there?
including this or before that? Is my
Nick,
question.
what number were you?
Well,
Okay, so 12. So
do we write it before or after?
Oh, they're up
Do you
there.
add the minus 2? Wait. Here. Okay, wait. It's. I think I like added that after, but I'm pretty sure you have to write it like after. So it's just 2 E. Or no, you don't need to write E. So I think it's just 8 because I feel like he wanted us to write it like
negative?
2 because I feel like he wanted us to write it like after. Oh no, I get you. That's just your working
One,
Yeah.
the more full it is, the more it wants electron. So that's, yeah, it's like, no,
I've
if
won
you're
9
like,
times, but I
just don't add, if you're 2 7, right? It's easier to add.
He's so easy to predict.
One to the eight.
He always
The other way, if Well, it'll either gain, there are other reasons for preferences, but it'll either gain 4 or lose 4. Usually it can go both ways.
Is there any
You
factor
run
like
that. You run that.
But we are couple of times that we go down from electron we are to be positive. So more or less is positive. Okay. Oh, where's my?
Lymphatic.
Yeah, put that. No, put it away. Where's my pen? Who's using the pen up here? Or did I put it down somewhere? It's on someone's desk? Oh, someone put it down here. Okay. We're looking good for the charges. We do have to make some decisions. 2 protons, 2 electrons, 3 protons, 2, 4 protons, 2, 5 protons, 2, 5 protons, 8 minus 4. Nope, I'm going to go 2, make it plus 4, and plus 1, plus 2, plus 3. Let's go with hydrogen. 1 proton, nothing, plus 1. And I think we have them all. Excellent. Okay. What do we notice about the most likely ion charges in each column or family?
They're all the same.
They're all the same. Was there anything where you had to decide which way you're going to go?
6 and 14.
6 and 14. If you, for this one, you decided to go 8 and you made that minus 4, you are equally correct. Carbon can go either way. If you decided for this way to do nothing and make it plus 4, you are also correct. Both answers are correct. Both of those can do it both ways. As you go down the family, they're more likely to become positive and give up their electrons. And the higher up, the more likely they are to attract the electrons. It's a little something called the shielding effect. Innermost electron shells that are full kind of block the full power of the nucleus from the other ones. The more that gets blocked, the more likely they are to let go. It's like when, like if you have like 10 kids, if you lose 1 or 2, it's not a big deal.
Yeah.
I used to have like 7, and now I'm down to 2, and maybe we should start keeping track. That sort of
We
thing.
have spares.
Yeah. Aaron is spare. Yeah. But either answer you can do is okay. But then once you get to here, now you start adding them, and it switches over to negative. These tend to be the non-metals. Those tend to be the metals. This one, however, is a little, they did way too much work. Because this was 2 protons, I'm assuming that is, then with a 2 on the outside. And then this is 2 protons, 2, but it would have originally been 2. Would it be easier to get rid of 2 or add 6? Actually, hold it. 2, 8, they did get rid of 2. That's supposed to be an 8 there. I was on the wrong row. 2, 8, that's plus 1. If you've taken away 2, what's the charge? Positive 2, which matches. This is why all of these have very similar chemistry. They all want to give up 2 electrons, and they all want to become plus 2. This is why if you, a lot of radioactive isotopes that we worry about, for example, there's a particular type of nuclear weapon that gives off a lot of strontium. Strontium is plus 2. Calcium in your bones is also plus 2. Gentlemen, I may dismiss by who has papers though. You should never be getting ready to leave while we're still in session. And because it has such a similar chemistry, it will actually replace calcium if it's in a lot in your diet, and it happens to radioactivity, that would be particularly bad. What time does the class end? We got 1 minute. So, one more thing then. Your teeth are mostly made of calcium chloride. That's the enamel.
Yep.
The reason we no longer get cavities is not just because you brush, but you brush with fluoride. Chlorine is -1. In the same family, there's fluoride, which is also -1. When you brush with fluoride, you change it into calcium fluoride. This bacteria have evolved to learn how to break down. Bacteria find it really tough to break that bond. It's just a little bit stronger. We discovered that because there are some indigenous people in the world who, after they started eating carbohydrates because of settlers in the area and they could actually get access to like sugar, in many places of the world, then their teeth went bad. Some places didn't because the water had natural fluoride in it, and that's how we learned that fluoride can do that. Similar charges will have similar properties. Okay, next day we're going to do Lewis dot diagrams and valence electrons. Last two gentlemen, you didn't ever bring out your notes. You just passed up. You right to the bell. When I start hearing the buzz, you create the activity in the classroom that, oh my God, we have to get ready, and then it's harder for people to listen. Don't pack up until after the bell's gone. Like every teacher in the world, the bell doesn't dismiss you. Yeah. Okay, go, run. Get to your next class.